Hello, this is Group 22. In this video, we will explain our project for Business Analytics class. Our purpose for this project is to identify a good criteria for stock selection in order to help amateur stock investors with their decision. Specifically, we seek the higher total dividend with possibly higher average return and lower volatility. We presume that P/E ratio is the one important criteria to refer to. To prove that, we constructed three linear optimization models. The first one is a general model where 55 stocks were randomly selected. The second one is a control model with 22 randomly selected stocks from the first one. And the third one is an experimental model, which also has 22 stocks, but this time we selected them based on P/E ratio. In each model, we designed a solver to choose which stocks and how many shares to purchase. Then we will draw a conclusion by comparing the last two models.
So for my part, I will explain how we choose the stocks. So at first, all the stocks we choose are from the Standard & Poor's 500. We use the random function to give each stock a decimal number between 0 and 1. Then we use the if function to assign number 1 to a stock that has the random number between 0.4 and 0.6 in the last step. If not, we will give it a 0. This is the first selection process we made. We chose 104 stocks from 500. Then we started the second time selection with the same method, which you can see in the tab named Full Stock Selection. For this time, we got 50 stocks from the previous 104. So in the tab Random Stock Selection, we choose 22 stocks from 50 to make one control group. You may feel confused with the tab in the second one named the Random Select, which has chosen 26 stocks out. When working on our model, we found that around 20 stocks sample size is too small. So we use the same method to choose more stocks and make the sample size reach 50. And to the final tab, the selections based on the P/E ratio. In order to make the result more accurate, we then introduce one new factor, the P/E ratio, to our experimental model. We created a dummy variable to select stocks with a P/E ratio lower than the industrial average P/E ratio. When one company's P/E ratio is below the industrial average, it usually means it is reasonably valued. But we also noticed that in real-world practice, a high P/E ratio of a stock usually means the investors are willing to pay a higher price for the stock, since they believe in its growth potential. To adjust the comparison between individual P/E and industry average P/E, we added the multiplier, and we will explain it in detail later.
Now I'm going to talk about each individual variables or the columns inside our Excel formula. So from column A to column C, it's just the name and the tick marks of our company, of our chosen companies, and also like which sectors they belong to. And for the column B, which is our decision variables, which is number of stocks we're going to purchase. And then from column E to column I is the performance of the stock for the past 5 years, also the stock price. And we average that out and we get a 5-year average return on column J. And then for the column K, what we did was we multiplied the number of stocks we're going to purchase and the current stock price and the average return to get a weighted return. And then we sum all the return together to get the total return. And then we use our total return to divide it by the amount we invested to get a average return for our portfolio. And for the beta, which is an indicator for the volatility, it's also online, and we search online for the beta for each individual stock. And so how we calculate the weighted beta is basically also using the number of stocks to purchase and the stock price and the beta it has. And then we sum it all together and divide it by the amount we invested to get an average beta for our portfolio. And then here's our PE. And since here, for example, in the random stock selection, you'll see that some PE will have a PE 999, which is abnormally big. It's because the original data shows it's not applicable, and it's mostly because the earn per share is negative. So this company do not have a PE ratio. So I give it a 99 to just basically kick it out from our selection. And then talk about our multiplier. So the multiplier is basically purely my subjective choice and opinion. So I score 1 point to the companies with growth rate between 0 and 5%, 1.25 points to the companies with growth rate between 5% 10%, and 1.5 points between 10% to 15%, and 1.75 points to the companies with growth rate between 15% and 20%, and 2 points to the companies with growth rate above 20%. And lastly, 0.5 points to the company with the negative growth rate. And I think after we use the multiplier to multiply with the industrial PE, then makes a comparison between the individual stock and the industrial PE, and we found it's more like a reasonable choice for our stock selection. And then we have our annual dividend, which is usually timed by 4 because most companies pay the dividend quarterly. And then for our total stock, it's just using the amount, the stock amount we purchased and multiplied by the annual dividend. And the stock diversity and the stock confirmation is just to check which industry our stock is chosen from. And here's our investment amount, which should be less than 5,000.
So now we can open Solver in Excel under the Data tab. First, we set the objective to be maximizing total dividend by changing the decision variables, which is the number of shares to purchase, with the following constraints. So the first constraint is the number of shares to purchase has integer values. The second constraint is the total investment value is less than or equal to the available fund, which is $50,000. The third constraint, the total weighted return, is greater than or equal to 0.05 or 5%. The fourth constraint, we have total weighted beta is smaller than or equal to 1 to keep the variability not too large. Our fifth constraint is saying the investment value of each stock is less than or equal to $5,000. And the sixth constraint, other than the constraints that appear in Solver in the model Excel file, we created a chart at the bottom of the Excel file to count the number of stocks being chosen to purchase in each industry to make sure the selection is diversified. And lastly, we have the non-negativity constraint. We set the model to linear, and then we click solve. So to conclude, in the model with 50 randomly selected stocks, the total dividend equals $2,433. The weighted return equals 0.05, and the total weighted beta equals around 0.93. In the control model with 22 randomly selected stocks, the total dividend equals $1,390. The weighted return equals 0.05, and the total weighted beta equals 0.9264. In the experimental model with 22 stocks selected based on PE ratio that is below industrial average, the total dividend equals $1,608. The weighted return equals 0.0918, and the total weighted beta equals 0.7311. So comparing the control and experimental models, we conclude that P/E ratio is a good predictor when selecting stocks to invest in to generate higher dividend, higher weighted return, and lower beta, indicating lower variability. And the values in the industry diversity chart of the two models are relatively similar, meaning the chosen stocks to be purchased are diversified across industries.
To practically help investors, there are still things to improve. Since many indicators and models that help making investment decisions are non-linear, we will need to make further research on those, such as Sharpe ratio, which can help investors to decide the proper return and risk for their portfolio. To more accurately evaluate how a company performed for the past few years, we may want to apply the stock, the discounted cash flow, and weighted average cost of capital to make better investment decisions. And that's all. Thank you for watching.